about how someone might use it and design an API to allow them to make this kind of change. So that's a slightly better example. What about something much more interesting? One of the quite common features you'll have on a point series is you might be able to add labels to each data point. So you might want to, above each point, you might want to have the value of the point and have that rendered. Now we haven't designed that into this series, and we could add that, but through exactly the same technique of decoration, we can actually do that very simply. So here, again, I'm going to cut and paste. I'm not going to try to type. I'll leave that one in there as well. So what we're doing on the enter selection is we're going to append a text element. We're going to do a bit of styling. That could go in CSS, to be honest. We're going to do a slight transformation to push it up a little bit, and we're going to set the text, as you saw with Chris's example. We're setting the text based on some property of the data, and what we get there is data point labels. And again, this is without having to design an API where I've explicitly exposed this as a concept. And one of the things we've been careful to do when designing these components is make sure that we add useful extension points. So for example, each one of these circles is sat within a G element, a container, which has the origin at what you'd expect to be a sensible location. So this allows you to very easily add a data point. And also, because you've got access to the full D3 data join, we can make sure we only add new text elements when new items are added to the series. So here I'm using the enter selection explicitly rather than the update selection. In this example, the data's not dynamic, so it's a bit of a moot point, but if the data was dynamic and changing, we'd have the correct effect as a result. Now, rather than go through lots and lots of different examples, I'm just going to show you basically where we're at with the project. What we've been doing is we've been trying to create lots and lots of little components at various different levels. So you've seen a series component, you can see it on the side here. We've added things like multi-series component, and then we've added some larger components, things like a spark line and a time series chart, which are constructed from little components, and they expose certain features of those components. One of the other things which is a little bit tangential, which I just think is quite interesting to call out, is one of the relatively big issues with working with SVG when you're trying to construct charts is SVG doesn't have a flow-based layout algorithm. So it doesn't flow in the same way that the HTML DOM does. So it actually makes layout a little bit of a labour-intensive process. Most of the D3 examples you see will have some kind of convention-based approach where you basically have a width and you have some padding and you manually position something based on its width minus 2 times padding, whatever. What we've done is we've added flexbox layouts. So when Facebook released React Native, they created a JavaScript implementation of Flexbox, and we were then able to use their Flexbox JavaScript implementation on SVG. So what you can see here is a quick example. If you add the layout CSS attribute, you can actually use Flexbox, you can call layout on the component, and here's a quick example. We're just throwing in a bit of code to colour the G elements. And here you can see very quickly and easily you can construct a layout which is much more appropriate for charting by using sort of more flow-based layout. That's a little bit tangential, but it's something I think is quite interesting. What I want to do is jump ahead to a complicated example. Now this is Yahoo Finance. This is the Yahoo Finance website, and it's a pretty complicated looking chart. We've got crosshairs, we've got a series, an area series, we've got, this is called an exponential moving average. It's just another series which is computed on the data. We've got quite a novel axis type here. This is a date-time axis, but it's called a discontinuous date-time axis because trading only happens between certain hours. They omit the nighttime hours from the data. So there's all kinds of interesting things going on here. And I can bet if you tried to do a pixel for pixel recreation of that chart with a commercial, or, well, I say commercial, any third-party library, commercial, open source or otherwise, that would be really hard to match. What I'm going to show you is what you can achieve with our library. So this is showing you the basic components. So within D3FC at the moment, the framework we've been messing around with, we've got things like area series, line series, bar series, we've got all the basic types, we've got things like crosshair, and this is just throwing together the correct components and doing a bit of CSS styling. And you can see functionally it's pretty similar, but visually it's really not quite there. This is showing you as much as you can do just with plain old CSS. But if you then make use of decorate, so if you then make use of the fact that it exposes the underlying data join, this is what it becomes. And the code here is on a GitHub gist, but this is around about 300 lines of code. It's not much code, and this is as a result of creating components with D3, but exposing the underlying power of D3. What's that saying?
Quite a lot of the example.
Which one?
On that one, you missed the y-axis.
Oh yeah, where's it gone? There it is. Oh yeah, that's cool. Yeah, so actually a quick bit of discussion here. So for example, these little bits here are horizontal line annotations where the default behavior is to create a line and add a bit of text. By decorating them, we've hidden the line, we've created this new little call out within the enter selection, we've constructed this thing, and because it all works with data join, if the data changes, this will all animate to the correct location effectively for free, which is quite nice and quite cool. So that's your presentation, that's my presentation, and this is pretty much the end of it. So, as I mentioned, we've been sort of trying out, experimenting with what we are hoping is a slightly better way of building charts. And what I'd say is this isn't ideal for everyone. If you want to just create a chart very quickly and easily, and you're not terribly concerned about exactly how it looks or exactly how it behaves, then there are a whole load of great charting libraries that will get you started really, really quickly, and you won't have to understand D3 to make use of them. If, however, you're quite particular about exactly what you want to achieve with the chart, if you've got some quite particular behaviour that you want to add to it, then we believe that this route, potentially picking up some of the components, or even just having a look at our code and copying some of the principles and ideas, we believe that's hopefully a better way to construct charts. And that's it for me. So, are there any questions? Yeah.
Just how large is the library?
That was a good question. I think we've got about 30 or so components. Typically, the smallest is probably 60 lines of code, the longest maybe 150. Probably the most complex component is the crosshair. And that's an interesting one in itself, because creating a crosshair that isn't actually stateful is quite a challenge. And it's taken us a long time to get to this point, because we've been quite strict about how we wanted to design it. So it's taken a while to get there. So with the crosshair, you push the responsibility of maintaining the data onto the consumer. It's a little bit of an odd pattern, but I think it works quite well. So it's not huge. I'm not here to market it as the solution. I want to illustrate a slightly different approach.
What's the FC?
Well, we started off originally because we work in the financial domain. We wanted to. There are quite a few sort of finance-specific ways of rendering data, which there are some charts which accommodate that, but it's relatively limited. So it was originally D3 financial components, because we originally started doing mostly time series charts and the kind of things you'd expect from financial charts. Then we kind of realised that it's more universal than that, so we just call it D3FC, and we'll probably make up some better acronym for it in the future.
Whatever you want it to be.
Yeah. D3 for charts is one suggestion we've come up with. Yeah. So is there a question back there? Yep.
Good question. You had a problem with your SVG. Could you not use Canvas at all?
D3 doesn't play terribly well with Canvas. D3 is about constructing elements from data. So whether you could construct HTML elements, you can construct HTML elements and SVG elements. It's got to be something that works in a retained mode rather than Canvas, which is an immediate mode. So the two don't really work together.
I suppose.
You're going to say they do. You can find out. There's probably a clever way.
Like Colin's right, you need a kind of retained mode, you need a DOM, that's what D3, sorry, I don't think I asked the question. Yeah, you've got you need a DOM to play with, really, that's what it's about. However, I kind of mentioned that D3 splits the algorithmic complexity from the kind of the rendering side of things. So if you were to actually start wanting to create a Canvas chart, be it WebGL or Quantity2D, you could definitely do it just building on the scales and the more algorithmic components that D3 gives you. So certainly if I had a hard requirement to make a Canvas chart, prior to doing this, I would have just started from scratch. But definitely now I would try and pick up those kind of algorithmic components.
Although the thing that you would be missing is the data join, and to my mind, data join is the sort of secret sauce of D3, and that's what made some of these examples possible, the data join. So you'd end up with a decent implementation of a Canvas chart with a good separation of concerns, but you wouldn't really be making use of D3. So, yeah.
What exactly do you do with cursors and other state-like things? Do you call a callback that the errors are through or something, or how's it work?
Well, Chris put together the crosshairs, so he probably knows best, but
I'm
from...
thinking in the context of React, because this seems like basically the first D3 implementation that actually can work with React properly, as far as I can see so far.
So when you say cursors,
You mean crosshairs,
Crosshairs.
that's the interactive components.
Or any interactions.
Can I show you, if we've got
You've
Wi-Fi, then I can show you an example, then I can explain kind of how the example works.
Do you want...
It was just the main example from the website.
Yeah. Oh,
So Colin will bring it up.
do you want the examples?
Just that one? Okay. So this is kind of, I suppose this is a bit more what you're after. And so in this case, what's happening is we are representing, so the kind of the most interesting bit, so we've got a bit of a cursor, but I mean, this isn't my laptop, so so I suppose that's kind of another example of it, where you're moving the window on the data. Now, I think traditionally, or maybe in a non-pure D3 way, you would render things, and then kind of outside of your render loop, you would maintain some state, and in that state you would have the visible range, and then you would just manipulate the visible range and then re-render, and that kind of visible range would be picked up. You would keep the axis outside of your render loop, so you modify the visible range on your axis, and then that would kind of propagate through, and that's how you do it. What we've tried to do is be really pure about it, and so D3 is all about going from data through to DOM nodes. So in this case, your state actually includes the visible range. So you make sure that the visible range, the range of the scale, is encoded in your data. So when you do the data join, you bundle in the visible range. So any interaction that you perform with the chart, any state that you want to inject into it, becomes part of the model, and then it's a complete re-render. And as part of that re-render, you see the effect of kind of the injected state.
So in concrete terms, for the crosshair, for example, you give the crosshair an empty array, and you give it a data model that the crosshair itself owns. So as you move it around, it will push and pop data points and transform the data point within your model. And as a result, your render can then do other things with it. So for example, your render can update this section here. Your render can actually create multiple crosshairs which are bound to the same data, and all kinds of interesting things as a result.
Yeah, you can obviously display things that are outside of the ground level.
Yeah. It is very, very React-like in that sense.
As I say, the other sort of D3 React bridges are pretty weak. They're based on the principle of manipulating them after they're in DOM, and then actually doing this kind of more functional stuff. So
Yeah.
this is pretty useful. It's going to solve some problems for us. I think. So,
Cool.
appreciate it.
Any other questions before we hand over? No? Cool. Thanks a lot.
Just a quick word, there's plenty of beer, so feel free to have as many as you want.
We don't want to throw away the beer.
If you need to go to the bathroom, whatever, it's getting a bit more complicated now, but take your phone with you, or tell one of us that you're going out and we wait for you. Otherwise you can't get back. You gotta wash your hands.
One second. What's the internet, the Wi-Fi password again?
Goes.
This one can actually nice desktop.
So hello everyone, my name is Nesher. I am a developer in a startup called Condor Social. I've been managing this meetup for about 3 years now, and I'm going to talk to you about ECMAScript 6 promises. So part of what I've been doing in the past couple of weeks is to start planning how we're going to transition all our applications from CoffeeScript to ECMAScript 6, as this is what the world seems to be doing. I'm going to cover a little bit of the background about what promises are. Apologies if you already know that. And then just go over the APIs of how the new ECMAScript 6 promises works and why they're so cool and why you should all be super excited about them. Let's start with a really simple question of what a promise is. I googled it, expecting to find tons of very obvious answers, and was quite disappointed to see quite a few tutorials and blog posts that completely avoided giving a straight answer. And when I tried to think about how to explain it in a non-technical way, just it was considerably more complicated than I expected. So I came up with this example. Bear with me. So as a developer, and I'm sure most of you have gone through a project where you've been supposed to deliver a big change. About 2 weeks ago, there's a slight sense of doom in the company, and while you're busy working on your code changes, your friendly designer comes along and with a smile on his face asks if you notice that one of the buttons isn't aligned correctly. You smile, you said yes, but if you press the button, the application crashes, and that's probably a bigger problem. But that doesn't seem to matter to the designer. And you can see the twitch in his eyes, and you know that you really need to fix it. But you really also need to fix the button first. So you tell him, listen, I promise I'm going to fix this, but I need to finish this first. So you basically give him an IOU. I'm going to do what you want, but I don't really know when. At which point, there's 3 possible outcomes. The first outcome, which we always hope for, is that after a few days you realize that actually you have some spare time and changing the button position isn't that complicated, and you fix it. You go back to the designer and you tell him it's done. He's really happy, you're really happy, and life goes on. The second option isn't so happy. After about a week, you realize that the button is still not working, and as much as you want to appease the designer, it's just not going to happen. And again, you can't just ignore him. You need to go and tell him, listen, I really want to do this, but it's not going to happen. And this is one option. The third option is that you actually had the time, you spent a couple of hours, you fixed the button, you went to the designer, he looked at you and just told you, no, now it's a pixel to the left, this can't be worked. And this gives us basically the structure of a promise. So we have a reference to an action or a value that will happen in the future. It can have one of 3 states. It can either be pending, I'm going to do it sometime in the future. It can be fulfilled, I've done it successfully, or rejected. I either tried to do it and failed, or just couldn't do it at all. A promise can only happen or succeed or fail once. And you should always really handle your promises. We'll get to exactly why, but if I failed to change the button and didn't talk to the designer, bad things happen. Now, in JavaScript, promises are mainly provided as a replacement for callbacks. And it causes a bit of a confusion as the syntax can often be quite similar. And I think that the main thing you need to remember when comparing a callback and a promise is that when you pass a callback to a function, you basically pass a box code, a function, that will affect how the function will actually execute. A good example would be a sort. You want to sort an array, but the JavaScript sort is quite limited. It only knows how to sort in a very certain way. We want to change that sort to work in a way that works for us, because we wanted to have like a descending number order. And the way you change how sort works is by simply passing along a function, a comparison function, that will completely change how the sort will operate. Promises work in a completely different way. Instead of passing something to the method, you make a call and you get an object, a regular JavaScript object. That object will know its state, whether it happened, whether the promise already happened or not. And we then have the ability to execute in the future action based on the success or failure of the promise. There's another small difference between promises and promises within JavaScript. So while ECMAScript 6 has just now made promises an official part of the spec, there have been other libraries, mainly jQuery, that have been using promises for a good while. They're not the same necessarily. So the jQuery implementation differs ever so slightly from the ECMAScript 6 implementation, and quite a few other libraries, while are similar to the spec, have different naming conventions. I'm highlighting it because some of the examples here will not work with some of the promise libraries that you may know. So this is how you create a promise with ECMAScript 6. You create a new promise object, and you pass in a function that has a resolve and a reject. As we said before, a promise must always either be resolved or rejected. Resolved when you succeeded, rejected when you haven't. You don't technically have to reject a promise. You can have a valid function that only resolves. An example for that would be a set timeout. A set timeout won't fail. It will always succeed. But in most cases, you're probably not going to create your own promises, but consume promises that were created by Ajax calls and similar libraries. So in order to consume a ECMAScript 6 promise, you use basically two methods, then and catch. Then basically accepts two parameters, two callbacks, a fulfilled, a success, and a failure callback. And you have a catch, which only handles the failures. Now, it's important to note that catch is basically the same as calling promise.then and simply not passing the success callback. It's a syntactic sugar. It's very useful when you write it because it looks better, but it does exactly the same. And there's one other thing. If you go back and you see that when you call the promise.then, you can provide two callbacks at once, the success and failure, which look like this, the top example. And while this is a valid syntax, it is highly discouraged, simply because if you have nested promises, you get into something that's very similar to callback hell, which I'll refer to in a few minutes. But basically, you start to nest promises very deeply, which no one likes. The preferred solution is to have a promise.then and underneath it have the catch. This also means, if you look here, that you can chain promises. Basically, every promise you create, whether you've rejected or resolved it, will result in a new promise, which looks like this. This is from the MDN website on promises. So you have the promise, a pending state, and then it can either be fulfilled or rejected using then or then and catch. It doesn't matter what you do after that. What matters is that the result is a promise again, and you can then change it. It will allow you to do some fairly interesting things, and we'll show them in a second. So let's make an obvious comparison between promises and jQuery. This is the old structure of jQuery. Again, jQuery now these days do support promises, so you can do it differently. I'm just trying to make a point here. So you have two callbacks, a success and an error callback, versus how you do fetching in the new ECMAScript 6. Fetch is the new alternative for the current I forget the name of the object. Yes. But basically, it's the equivalent of a jQuery Ajax call. And you have a then and a catch method. Again, you don't pass the properties at callback inside. You get an object back, and then you call on top of that. If we put them one beside the other, they might look quite similar, but there's a few obvious advantages that should convince you to use the ECMAScript 6 promises. The first being, we save the line, which I think is an important advantage. Thank you. No, I'm kidding. It's not that impressive when you do a very simple callback. If you're only going to fetch a single endpoint, it's nicer, but you shouldn't be excited about that. The real problem with callbacks happens when you need to do multiple calls. Let's say I need to first authorize the user, then fetch a list of items, and then fetch the detailed item list on the middle panel, which is a fairly obvious use case that you see in many websites. This is a simpler example with only 2 callbacks, and you can see how deeply it starts to nest. Now there's 3 problems with this. Flat is better than nested. This is a Python thing, but it really does apply to every type of code. The more you nest your code, the harder it is to follow what's happening, and you really want to avoid that. You need to repeat the error handling. So here and here. Again, there's ways around it, but it's not really the obvious way of doing things. And it's really hard to reuse because you're basically hard coding the entire chain. Again, there's ways around it. How do you do it with promises? So promises work a lot simpler. Since the result of every promise is a promise, you can change them. The nice thing about the results of promises is that if you return a promise from, if I resolve the first promise and return a new promise, it will now wait for the new promise I created to resolve. So we wait for this to complete, then we call whatever process we want to do, and at the end we're going to catch all errors. Now it's important to note that much like there's like a famous question, if a tree falls in an in the forest and no one's there to listen to it, does the tree actually falls or something like that? Promises work slightly similarly. If a promise was rejected and no one was there to catch it, the promise will fail, but you'll never know about it. And this will cause you a lot of pain down the line, simply because you'd expect something to work, you won't see any errors because the promise, the way promises are structured, you're meant to catch the error. If you don't catch the error, it just goes away. If we go to the original example side by side, again, this is starting to look considerably more obvious why promises offer an advantage here. Again, one thing to be honest, you can catch rejection multiple times. I'm only catching the errors at the very end, which you should always do. But theoretically, I can also catch the error after the first promise and handle that differently, depending on your use case. Now, another nice thing that promises do, again, because they resolve and can be chained, is that you can actually transform the values of the promise over time. Which means that if I'm fetching an XML, which still happens, sadly, I can have the first mutate that XML into a JSON file, and then do something about that. Again, much nicer than having it inside callbacks. The last really important bit of promises that again can be extremely painful with callbacks is making parallel calls. So in the original example, I showed you what happens or how you deal with consecutive calls. I need the value of my first call to make the second call, and I need the value of my second call to make the third call. But there's times where you just need to fetch several endpoints at once, and you don't really want to wait until the first one arrives before you fetch the next one. But you also do need to know when you actually got all the data. One of the help methods that you get in promises is a method called all, which basically gets and accepts an array of promises. They don't have to be Ajax calls, but it will then wait for all those promises to resolve, and when all those promises resolve, you will get your then, basically. If one of them fails, you get you'll be able to catch it. If everything does resolve properly, you'll get an array with all the results of all those promises. Another interesting thing you should be aware of, even if you're not really doing a lot of Ajax calls and promises might not seem immediately necessary for you, Promises were originally meant to happen in the DOM and are actually going to be part of it. So new DOM APIs are now going to be based on promises. I think fonts is one of them. There's a couple of others that are now starting to roll out. So this is going to be useful in quite a few use cases. Browser support and polyfills. So like everything in life, it's not supported by Internet Explorer. Firefox and Chrome latest do support it. WebKit, I think, has it on 90 builds, but isn't supported on live. The solution for that and fetches and quite a few other ECMAScript 6 capabilities is polyfills. There's an excellent library called Babel.js. I highly recommend you to check it. It does a lot more than just polyfills, but there's tons of alternatives you can use. When I started doing this presentation, I came across two things that I thought are worth reading through or watching if you have the time. The first is an excellent article on promises by a guy named James Nelson that actually has some exercises you can do to make sure you understand how promises work. It shouldn't take you more than 15-20 minutes, and I'll put the presentation online. So
Yeah, guys, memory aid.
no problem. The other thing, and I end up preparing a whole different presentation about this. So when I started to talk about promises and callbacks and async calls, I started to talk about, well, I wanted to talk about how JavaScript is a single-threaded environment and how promises or callbacks actually happen. Because you're basically sending actions outside of your event loop. It ended up being a fairly long presentation on itself that didn't really talk about promises at all. And then I realized that there's an excellent video online that does a much better job. This guy, Philip Roberts, actually created a JavaScript app that replicates the JavaScript event loop, and you can actually see how stuff actually happens in the background, including the refresh. So again, it's a 20-25 minute talk. I highly recommend it. That's about it, about promises. This is the point where I will answer questions and invite you to drink with me as a pub. Questions? Yes?
With the promise all, would it be possible to promise then for the all firing? Like if you want to,
Yeah.
You can do one on the first and then it fire all of them. Is that right?
Sorry, so the promise all returns a promise. So you can do it then on that promise itself, if that's what you mean.
No, so I was wondering if you'd say you wanted to manipulate the data from call one
Oh,
for all,
yes.
but then on that promise.
So you can have the call one dot then and manipulate it, but you have no control on what's going to get called first. Yes. Any other questions? Yes.
When you do the then you're chaining them together,
Yeah.
what happens if the first call fails before the second call goes to the then?
So
Yeah, what happens?
yeah, there's a nice schema in the article I gave. I mean, basically, it's going to skip the next then, but then it will continue as
Okay,
usual.
so it's similar to a try catch.
Yeah, you can think about it as a very large try-catch. Yes?
I really like promises. I use them a lot in things, but one thing I found really hard about is when an exception is thrown inside the promise, basically the promise will just swallow the exception, it won't print out to the console.
Yes.
Do you have like a better way of doing this? Because it's really annoying. I
Yeah.
have breakpoints everywhere to keep capturing these exceptions.
So with, I'm not sure which library you use, but as long as you have a .catch at the end, it'll catch any breaking any rejected promise along the line. You do need to always have a .catch. You should never have a promise that doesn't do it. I know it's annoying, but I'm not familiar with a better way. Yes?
Careful, if you're using jQuery, that was one of its big differences from the promises spec that got implemented. jQuery used to have the behavior of swallowing any thrown exception within a then handler. Now the promises spec says if there's an exception thrown in a then handler, it would trigger the catch clause kind of further down the chain. So that is a big difference between jQuery, which is probably what you're used to, and then promises.
I presume if you put a parameter on the function you've got in your catch, that would be the error information and then the exception information.
It depends where it happens. So I did the tests and I understand it may differ a little bit between browsers. I didn't have the time to test on all of them. Theoretically, if you made an Ajax call and the call didn't return at all, like you get a 500 error, it'll go to the catch. But if you rejected the promise from within the then, it won't get caught by the, like if you pass it like this, where you pass two methods in, two callbacks, if you rejected it inside the first callback, it won't get caught on the second callback.
Right,
So if you add a catch,
Yeah, if you add a catch, it'll be fine.
because this is one single resolution of the promise.
Right, okay.
Yes, but catching promises is a thing you just need to learn to live with. I'm so sorry. We have promises in quite a few places in our code based on jQuery. It caused us infinite amount of pain initially, but once you get used to it, it does make life easier.
And if you're doing an XHR request and then passing some JSON, there's quite a few places that things can go wrong anyway, so you'd be foolish not to catch it one way or the other.
Oh yeah, one of the ways we used promises is for modal dialogues. So we create a promise with the dialogue, and then once you okay it or save it or whatever, we'd return the promise with the value, which worked excellent until we realized we didn't catch any errors there. So if you failed in the modal, you'll never know it. Or if you canceled, there's an uncaught rejection. You need to always catch your promises. That's part of the thing. Any other questions?
Sorry, it's kind of unrelated to your call, but because you've got that slide
Yes.
up and I suppose I'm doing a survey in my head. You kind of the ES6 kind of lambda or fat arrow notation at the bottom, and you've got a single value or single argument lambda, and you've chosen to wrap the argument in parentheses.
Yes.
Is that a conscious decision?
I may have randomly copy-pasted code from around the web, and then I did try to use like the function standard, and may have missed in a few places.
Sorry, it's not a criticism.
Yeah.
It's a genuine question because I know it was kind of something that was raised in our office when someone was running through this stuff.
You don't want to have this guy as your code reviewer.
Now we know.
You're missing a thing as well.
Yes.
Because you can be pasted.
Yeah. So yes, I don't have internet at home at the moment, so I can't really. Never mind. It's been a hard week. That's all I can say. But yeah, I don't have an answer for that. It wasn't a conscious decision. I will put this. It's a Google presentation. I'll just share the link on the meetup page. If there's any other questions, I'll be happy to answer. Otherwise, yes.
You said that the then or catch return a promise. So what if I return another value? Is returned as a result of the promise, or?
Yes, it's returned as a result promise. You can create a promise and resolve it immediately. You use it when you need to pass a promise. So if I need to pass 4 as a resolve promise, I can do promise.resolve for, and it will create an automatically resolve promise. Yes.
The promise all,
Yes.
the example you showed, I didn't. Where's the catch in that?
Imagine it though.
Do you mean hypothetically or physically?
No, you're right.
It should be there.
Yes.
Yeah. And can you have separate catches for each?
For each one?
Yeah.
Again, so theoretically you can handle each one of those promises individually. So you can also have a call one dot catch outside
Okay,
of the all, and it will work fine.
I think the power of promises is it gives you a standard API for asynchronous things. And once you've got a standard API for that, you can then build things that operate upon that API. And promise.all is just something that operates upon that API. So you could then create an API where you can choose to do things sequentially or concurrently, or you can do higher order things on top of it once you have that common API. And that's, to me, the kind of power of promises. It allows you to think at a slightly higher level.
What he said. No, but yeah, I agree. Okay, we're going to the next door pub. You're all invited. You basically go down, turn right, and then turn right again. We'll close here. Join you. Thank you very much.
What was the question about the
No, no, no.